And he doesn't look old enough to have also had a 27-year career in the National Oceanic and Atmospheric Administration, but apparently it's true. He's come back recently from India, Fulbright Project, and his current presentation is Relational Science, a Theoretical Framework for Psi Phenomena. John?
Okay. You good? Well, thank you for this opportunity to speak here, and thank you to the organizers. This is my second SSE conference. First one was last year in Boulder. And I have a confession to make. I arrived there very skeptically, and I thought that I wouldn't be that interested. And then I was absolutely blown away by what I heard. And that's what convinced me to come here now and talk a little bit about some theoretical foundations. Because I think we need to go into that domain. I know that theory is either boring or controversial, but I think we can't avoid it, because my answer to the question posed last year as to why these phenomena are not more widely accepted and studied is that we don't have an integrated theory for it. We don't have a framework that can pull together all of our different theory foundations. And I think science requires that. I think that's always been the case in science. You'll see even Kuhn's revolutions don't take place until there's a theory that comes out. You saw that in evolution, certainly. You saw that in continental drift and quantum theory. We're probably still waiting for the final theory in quantum. The work that I've been doing in building a theory is based on the work of Dr. Robert Rosen, who died in 1999. I'm going to start passing this book around, just it may make it around in 20 minutes. And unfortunately, fortunately, he decided to look into the question, what is life, following the question of Erwin Schrödinger. And he was so interested in this as a kid that he dedicated his life to it, but he decided he had to become a mathematician first to be able to deal with it intelligently. So he became a mathematical biologist. And it is a problem whenever we go against the mechanistic paradigm, as we call it. But in fact, what Rosen did was he went to an earlier epistemological stage, as he says here in this quote, before the restrictions were made in mechanistic theory. And there were some very severe restrictions made in what we could legitimately study. It had to be something that could be quantified. It had to be something that was basically state-based. And I'll talk a little bit about that as I go on here. But to sort of provide a little bit of comfort, perhaps, to mechanists, I being one, I started in physics and then moved to ecology, thinking that physics could do something for ecology. Now I'm an ecologist, and I actually think that ecology can do something for physics. And that's what I hope to present. But this is a more general view than mechanism. It's not an alternative. We don't replace or throw out. We don't say Newton was wrong. If I build a house, I'm still going to use Newtonian principles. But the problem is it's limited to a special class of systems called mechanisms. And if we go to living systems, and certainly I believe that the phenomena I deal with in ecology and that we deal with in biology is as anomalous as psi phenomena when it comes to a mechanistic theory. So I'm driven there as well. And of course I also have one foot in the spiritual camp too. So we have to broaden our concept of nature, not replace it. This is the work of Robert Rosen. He's written a number of books. He started off looking at the fundamentals of measurement, anticipatory systems, and then probably the best read or easiest to read book is Life Itself, which I'm passing around now. Essays on life itself followed, and then after his death, his daughter has been publishing some books that he had in the works. I'm working with his daughter now, and we're doing workshops, and I've been trying to continue the theory work, and I think just this year, we've gotten some pretty good insights into it that allow us to think that we should start doing workshops and more distribution of the ideas. So what is the essence of the theory? Well, many of you will be happy to know that it's an explicit representation of matter-mind relation. Now that also may put off a lot of people and say, oh, well, that won't work. You can't go there. That's been tried. But in fact, I believe that's what he did. He didn't put it in those terms specifically, although he did write papers about mind and matter. But it is an explicit formulation of that relation. He described it as modeling relations, first applied epistemologically to how we do science. We make models of systems we study. But reading between the lines and also his specific statements about how general the theory turns out to be, it actually applies to nature itself. And so you see these two diagrams here. One, Rosen's modeling relation, which is a relationship between a natural system and a system of description, a formal description or a model. I'm drawing obviously the analogy to Escher's diagram. So taking that as a natural phenomena, this is very much like nature copying itself. So in the one sense, in mechanistic theory, we describe nature, somebody used the word syntax earlier, as a syntax, and the meanings and the description and the model of that we keep separate. This is putting the two together. So one way to look at that, if you think of if you think of the genie as representing the law, okay, we have science on the right-hand side describing nature. It's a one-way arrow, and we've all heard about the Platonic realm where natural law exists. Well, that's this mechanistic genie. But here's this gorilla saying, do you have a law that makes gorillas? And challenging the genie to a game of 20 questions. In other words, there's some creativity on this side. There's something that life does that is anomalous. And the genie sitting back there saying, no wishing for more wishes. I've given you life, don't ask for more. But I think life is going to demand more. So natural law as a specification for nature probably doesn't work. So now here you have to give me a little bit of license here because I tried to capture the history of scientific epistemology on one slide to try to get a sense of what's going on. But if we begin with Newton and Gauss, we have a picture of nature composed of stuff in space and time. Okay, there's pre-existing stuff, particles in empty space, so Newton's idea. I'm sorry, Hertz, not Gauss. Hertz hated that idea. He said that's too metaphysical, too mystical. It's action at a distance. And so he liked an idea where nature was connected as a lattice, as an interconnective medium. And of course, he then went on to invent wave theory. So then we took both. We have particle and wave theory. Okay, law is separate from nature, as I was describing. So we have law-like perfection, precise description. You have the idea of a clockwork universe. Excuse me. And it's also a dualistic worldview. In this view, you cannot explain the origin of a system. So if you try to apply this to the origin of species, what are you doing? There's no way for a system to self-organize because it's dictated from the outside. And mind is not a natural thing. It's something that the scientist has. Okay, and you have this idea that from James Jeans, a quote, God is a mathematician, and that's where we were. Okay, but then what happened? Well, suddenly we discovered the atomic world, and things got shook up a little bit. So now we have a question mark in this absolute rigorous application of law to nature. And where does that go? Well, we have to move that arrow where we first thought the particles and the waves were related to nature itself. Now we have to realize that the particles and waves relate to our description of nature. And then you have Korzybski capturing this in his famous statement, the map is not the territory. Okay? But now, and then you have this incredible discussion between Einstein and Bohr, where Einstein's not happy with this indeterminate universe. He says there must be some reality behind the dice. God does not play dice. And Bohr was saying, well, I'm sorry, that's the best we can do. Stop telling God what to do. Okay, and then Gödel comes along and shows that mathematics is incomplete without a mathematician. So now we have to move that arrow up even further and involve the mathematician. Okay, well, if we can do that, maybe our original concept of what nature is composed of might be different too. And if we have a different composition, a different set of terms of reference, we can come up with a different kind of analysis that may be broader, more inclusive, perhaps include mechanism, but allow us also to deal with living phenomena and psi phenomena. And if we do that, then we have to think that nature is perhaps doing that as well. And so Rosen, chapter 5 of that book that's circulating, is entailment without states. It's chapter 5 of life itself. So another way of seeing this, okay, seeing nature differently. If we think of nature in the original idea of particles and waves, here I have a picture of wavicles running around, okay? And we have the mechanistic genie describing that. What we're saying here is that we're going to replace that with a concept of nature modeling itself, mind in nature now, because there's a natural model there. And we have to think about what that means. If we were to describe that kind of system, which is technically called an impredicativity in mathematics, and it was thrown out in order to get mechanism, if we try to model that with a mechanistic point of view, it requires an infinite number of mechanisms. This is one of Rosen's main conclusions. But we have this, I'm going to use Occam's razor in the reverse direction to where most people would apply it to argue against this kind of view. I'm going to say it actually favors this kind of view because an infinite number of mechanisms cannot possibly be parsimonious. Okay? And Occam's quote is, it is vain to do with more what can be done with less. So now what we do is we put the law in the system. The system generates the law. The law describes the system. If we do that, what do we have? Well, if I'm sitting here in the universe and I'm looking outside at the cosmos, I'm inside the system. I still see a general system with general laws. So I still see the picture that I would get from a mechanistic point of view. But there's a big difference from outside the system. That's like looking at your teenager and trying to predict what they're going to do. There's a model inside, and you can't predict it. Okay, so if we do that, we have to do the same thing to nature, to science that we do to nature. And of course, we know that there's a relationship between our thoughts and our brain. So that's on the scientific descriptive side. And we're describing something that does the same. It also becomes obvious that this is a nested relationship. So I don't get rid of an infinite regress with this sort of theory. However, the difference between the infinity here and the infinity in a mechanistic theory is that this one allows you to describe a complex system at one level, whereas you would need an infinite number of mechanisms to describe one complex system. So it allows us then to think about and describe complex systems. You know, I just got back from India. I'm also very interested in some of the cultural and spiritual basis for this kind of thinking. It correlates extremely well with the ancient wisdom in the Vedas and Upanishads. And here's a quote from the Madhvidya, and you can read that. Likewise, this luminous being in all existence, and that luminous being incorporated in the body, is the same as that self, Atman, that immortal, that Brahman, that all those selves are contained in that self. This is the teaching of the Upanishads. And I think if you read that quote from the Upanishads and you look at my diagram, it looks like a caption. Most people here probably know that the early quantum physicists many of them, or not most of them, were students of the Vedas and the Upanishads. Here's a quote from Schrödinger, but Oppenheimer onward. So, okay, I said I was an ecologist, so what am I doing with these ideas and why? Here's another way of looking at it and the way I see it in nature. Imagine, okay, here's a tree. And you see the tree senescing and dropping its leaves in winter. Well, the idea here is that the tree contains a model of some kind. And it's an internal model. And here's the tree in the forest. You know it contains a model because the model can be fooled. If it gets the wrong cues, it'll still go through its cycle of senescence, and maybe it'll die as a result because the climate isn't appropriate. So the model drives the actual behavior of the living organism, which is then adjusted to the environment as an anticipatory system. And this is why Rosen wrote his book on anticipatory systems. Okay, we can look at this also taking Rosen's relation on the left, which is really an ontological relation, if you understand what I mean by that. It's what we think nature is doing, but we can't directly observe that. It's our philosophical construct of nature. Even the idea of a particle was a philosophical construct, and we try to observe it and it goes away. Okay, really his natural system and his formal system represents the ontology. How do we get handles on it? How do we turn it into a science? Well, it turns out that you can see there's an information relation he's describing here, and you can see that decoding is what the model is doing. Encoding, of course, we encode the model and then it decodes, so it's a relationship in that manner. Well, this is very much like an information system, and it is information in nature, like Gregory Bateson said. I realized that decoding is the same as function, encoding is the same as structure. We're abstracting structural ideas from nature, and that's what we call structure. And here, as we express the tree's model or the gorilla's model, that's expressed as functions. And these are the terms of ecology, structure and function. So it becomes an explicit theory of structure and function. And more than that, we can look at those four quadrants and we can see that this represents kind of a natural whole. And I'm calling it a holon after several other people have done so. Ken Wilber uses that a lot. It was originally coined by Arthur Koestler in the book Ghost in the Machine. But you see, these quadrants are very important. We know what measurement is. That's where we abstract qualities of a natural system. Here is where we interpret that. This is where I'm doing my work now, building niche models. The ecological niche goes here because it is a representation of a potential or a pattern in context. And that pattern can then be expressed. And this is where you get intentionality or an anticipatory driver of the system. It's expressed through functions, and then here you get your dynamics. So in fact, right now I'm working on turning this into an informatics system, an information system in a computer, where we can relate dynamic models to niche models in order to simulate a complex system. And I maintain that this is a very fundamental structure, this four-part holon. Somebody mentioned syntax and semantics. You can see how that divides. What's on the left side here is mechanism. This is what we previously limited science to. Here we're dealing with intrinsic qualities of a system. So we do get this duality between the intrinsic and the extrinsic. It also applies to space-time, by the way. If you look back into Greek philosophy, it corresponds with Aristotle's four causes, precisely. And as I said, I was reading Ken Wilber. He did an analysis of social systems and social hierarchy belief systems. And he first looked for a common hierarchy that they all referred to and couldn't find it, and he was ready to give up. Then he realized that they sort into four categories, and he came up with what he called a social cultural holon. And it was identical four categories, except in his book, they're flipped left to right. It's the only difference. Okay, so some of the implications of this theory. Now, here I'm speculating a bit and just trying to make it more relevant to the topics here. But you can see that what I'm doing, whoops, is advancing the slide too early. In each case, I'm seeing that this is a possible resolution to a major controversy. I have 1 minute. So I won't read through all these. You can choose the one you like, but Mind is always involved in nature. It is as real as matter. There are two worlds, and both are natural. There was a question about, do brains produce minds? And we had discussion at the break that well, perhaps there's something more elemental in mind that is in nature, because every evolutionary capability is an amplification or an elaboration of an existing property of nature. The eye did not produce light. It produced images. Light was required in order to produce an eye through evolution. And I think it's directly analogous with the brain. And finally, is this science or is it pseudoscience? I did, 20 years ago, quite an extensive look into the epistemology of this kind of thing, and there's basically 6 criteria for a valid worldview and for a valid revolution or shift in paradigms. Generality, consistency, necessity. Is it parsimonious? Can it be expressed in formal language, and is it useful? And I think this theory meets all those criteria. And my time is up, and my talk is up. Thank you very much.
All right, we can have questions. Go ahead, Bob.
Along, is your mind driving towards equations that will help us with prediction?
Prediction? Yes, but it depends on what you want to predict. If you want to predict states, use dynamics. In relational theory, we would predict organization of a system. Now, how can that help with your state prediction? Quite simply, if you imagine that the organization of a system will act as sort of a control information on your dynamics, you have a regulator. And it turns out that you can't combine those two. You can't take the control information from the potential side and include it in your dynamic prediction. But you can use it to regulate and modify your dynamic prediction. And that's the basis of the informatics system I'm trying to build. Yes?
In the 4 options that you presented, does information flow from 1 to 2 to 3 to 4? And does it flow in both directions?
Yes, the counterclockwise arrows that I've drawn are I did that because I started out as a reductionist and I'm thinking deductively. And so I'm thinking of measurement, and we measure structures out of some more complex whole. But if you draw the arrow in the other way, you get inference. Or induction, actually, not inference, but induction rather than deduction. So, if I have a structure, where did it come from? If I have a natural system behaving in a certain way, what functions must be involved? I'm inferring, inducing. Good question, yeah.
Another question? All right, John? Dr. Kineman, thank you very much.
Thank you.
You're going to grab your microphone.
Yes.